Good afternoon to all, and I'm happy to be here in this particular conference to present our new innovation in the area of industrial wastewater treatment, recycle and reuse. In fact, many speakers since morning, since our inaugural session, have stressed upon the importance of doing innovation and developing newer technologies for wastewater treatment, recycle and reuse. And we are happy to say that we have developed a new technology at CSIR National Chemical Laboratory, Pune, and we have our own device for the treatment of different type of wastewaters, and I will be presenting some of the results. In view of the short time, it is not possible to give the technical details, so I have given the reference for the publication or whatever patent, etc. on this developmental work. So you can go back to the reference and get more details. So let me start with my presentation. Next one. Next slide, please. So those who have visited National Chemical Laboratory, we have a very beautiful campus in Pune and many departments. I belong to Chemical Engineering and Process Development Division. Next one. So basically, this is just the introduction slide. Many of you are aware of this work and this background, that how much water is available. Especially, I have given the scenario concerning India. Basically, we have only about 10% water available for domestic, for industrial purpose. Domestic use is around 10% and more than 80% use is for agricultural. So we have agricultural based economy. So if we do parametric sensitivity per se, then if we reduce our consumption for agricultural sector by 10%, lot of water can be made available. So many speakers are pointing towards the policy decisions. So one decision also can be in this regard, that how we can reduce consumption. Of course, now there are many irrigation, different patterns, etc. I am I'm not expert in that area. But then this is one area where we should also look for reducing water consumption in agricultural sector, so that water can be made more available for domestic purpose as well as for the industry. Okay. So the key issues in the water recycle and reuse is basically, can we avoid liquid discharge? The answer is no. Then if there is a liquid discharge, of course we need to treat it properly, and if we have to release it in surface waters, then there are certain norms that have to be met. So can we reuse the treated water? And that is exactly the purpose of this conference. Definitely the water can be reused if the appropriate treatment can be given to the waters. Now the most important question in water recycle and reuse, why people are not doing, the earlier speaker showed that we have only 10% on an average, 10-20% recycle reuse. Why people are not doing water recycle and reuse when it is possible to have water recycle and reuse? The main reason is how to manage the process economics. So in terms of money and space, like the earlier speakers have shown, biological treatment processes, they require huge spaces, okay? And in places like Pune, Mumbai, Delhi, where is the space available? The cost of treatment is another, per meter cube of water is another concern. So you need to manage the process economics. Whenever we deal with industry specifically for their wastewater treatment problem, the first question that is asked is, what is the cost of treatment? And if the cost of treatment is manageable, then only the industry prefers to go for waste, because it is not a product. It's something which is a requirement for them, or it is a constraint forced upon them. So basically, it is not like a product. So industry like pharmaceutical industry, where the product cost is very high, then they can afford treating their wastewaters even when the wastewater treatment cost is very high. For example, in pharmaceutical industry, some of these industries, the cost of treatment can be as high as 400 to 1000 rupees per meter cube. Whereas for small industries like dye industry and industries such as small scale industries, they want cost of treatment less than 20 rupees, 30 rupees per meter cube. So you have this huge gap in terms of treatment technologies, and that is where we need different type of technologies. In wastewater treatment, no one technology is suitable for treating all type of waters. So we need to evolve different treatment options and then combination of different treatment options, so that we have techno-economically feasible option for industrial wastewater treatment, recycle and reuse. Next one. So we have different technologies right from coagulation. People have been using coagulation widely, then membrane adsorption, biological, and in NCL we have developed this hydrodynamic cavitation technology and new device for that. Next one. So these are the conventional devices. Hydrodynamic cavitation technology is not new. It is there since decades. But then the type of devices that are used for hydrodynamic cavitation, they are commonly orifice, venturi, and things like that. And they are more of academic in nature. They were not successful in industry because of their poor efficiency and of course cost of operation. And for industrial dirty wastewaters, they are not suitable. So for practical applications, they were not suitable. That's why we developed a new device. Next one. And this slide shows the design of our device. We call it vortex diode. It has nothing to do with electronic diode. It is just the name. Vortex is basically the pattern created for the technology. So we have vortex-based cavitation. We have a tangential inlet. You can see the typical device there. We have a tangential inlet whereby we create vortex in the chamber. We have a very specific chamber. That is what is patented. We have already more than 10 patents granted on this, some more patents filed on this development. Okay, this device is also available commercially now. Okay, there is a startup based on this development, they are selling the device. Okay, so this is the vortex based cavitation. We generate vortex such that there is a sudden pressure drop offered at the point, and then at that point, part of the liquid flashes into vapor, okay, and then bubbles are generated. Once the bubbles are generated, we allow them to collapse. This collapse is inward. So we call it implosion. So it is opposite of explosion, but then it creates the similar kind of extreme conditions. So implosion creates conditions such that there is a sudden high pressure, high temperature condition at the point of implosion, only at the point of implosion, not in the bulk. Okay, of course there will be some energy dissipation, and because of that some temperature pressure rises, etc. But then at the point of implosion you have temperatures of the order of 10,000 degree Kelvin, pressures of the order of 1,000 to 5,000 atmosphere. Okay, and because of that water splits and hydroxyl radicals are generated. These hydroxyl radicals, as you know, they are highly reactive oxidizing species, and because of that oxidation of organic pollutants takes place. And then there is a destructive mineralization. The organic moiety is destroyed and only carbon dioxide and water is generated. So this is a destructive technology. There is no secondary waste generation. Okay, so even if we get something like 50%, 60% efficiency with this technology, you should be very, very happy, because then it reduces the pollutant load in the next processes. Okay, so this is the overall technology. It is also we got recognition that it is linked with the United Nations Sustainable Development Program and things like that. These are the list of patents that are granted. We have also developed a technology for drinking water treatment. I will not be dealing with that right now in my presentation. So I will be now giving you some examples of industrial installations where this technology is implemented. Next one. So for pharmaceutical industry wastewater, this is one area which is neglected in India particularly, and the level of whatever API pollutants that gets into the surface water, and if we are drinking that water, then you can just imagine what are the consequences. Already people are getting drug resistant. Okay, so when we are not well, we go to the doctor specify medicine, and you say that medicine is not working, because unknowingly we are taking some of these API pollutants which we should not be taking, and this area is requiring a lot of attention in recent times. So you can see some of the concentrations in surface water which are very, very high. In fact, in one of the presentations in some conference, one speaker showed a slide. A patient goes to doctor and says that he has these problems, and doctor prescribes him glass of polluted water. Drink this and you will be fine. The meaning was that so many API pollutants are in that water that you will drink and you will get whatever those medicines are required for that. So unknowingly we just throw our medicines in the dustbin and they get into the surface water. Next one. So pharmaceutical wastewater treatment is very, very important, and it is in industry also and in surface water also. Okay, in surface water we normally take care of only COD, BOD. We don't take care of individual components. So we need to take care of these API pollutants because these are emerging pollutants extremely in small concentrations. So we need to take care of these pollutants. Okay, so we have done some experiments with metformin. You can see some of these examples. Next slide, please. Then for ciprofloxacin, some of the common medicines, you can see more than 95% or close to 100% removal takes place. And this is by destructive. There is no secondary waste generation. The component get destroyed completely. Next one, please. Then cephalexin. Here we have a new development. Cavitation I described you previously in my presentation. Now we have developed a new reactor which will also offer catalytic activity in the cavitation process. And this is a new development recently published just 1 or 2 months back. It is called dual activity cavitation reactor. Next one. Now, apart from this pharmaceutical industry sector, another sector which requires a lot of attention, especially in dye industry and many other bioprocessing industries where ammonical nitrogen is the main culprit. COD is not a problem because there it is all biologically degradable components. So you have biological digesters working very fine, but then ammonical nitrogen is a major problem. Close to 700 ppm ammonical nitrogen you get in wastewaters, and you have requirement below 30 ppm. So this technology is also quite useful for removing the ammonical nitrogen from wastewaters. Next one. We have developed a new process now. I discussed about the new device. Now we have developed a new process which is called solvent assisted cavitation. So we are taking advantage of a process modification where we are taking or we are exploiting the interfacial reaction between the organic moiety by adding solvent, because solvent is like more close to organic component, and then we are exploiting that interaction for destroying the pollutants. So this is solvent assisted cavitation. This is recently we got this patent and we have recently published on this, but so far not much work has been done on this subject. Next one. So this is again, next please. Next slide please. Now I will give you some examples. Fishery industry effluent. Now fishery industry effluent is almost BOD containing, so biological digesters take care of that effluent. Ammonical nitrogen, as I said, that is the main problem, and then this technology can be very useful. You can see the temporary industry installation in the fishery industry. Okay. Dye industry also you have similar example shown there where we get something like 82% removal. Next one. Fertilizer industry is a big complex and different plants are generating different type of effluents. There also some of these streams are high COD content, some of these streams are high ammonical nitrogen content. In fact, sometimes you can get COD more than 1 lakh, and that is where you require specific technology, and this technology is useful even when COD content is as high as 1 lakh. Okay, next one. Now this technology is getting more popularity in distillery industry specifically, because distillery industry per se, that is the generated effluent is very strong in COD, BOD. You have COD close to 1.5 lakhs and BOD more than 50,000. So here we have biological treatment in place. Okay, so here we are not employing this technology for removing COD. What we are doing this, by employing this technology, we are converting part COD into BOD. So that generates additional gas. So we get something like more than 20% increase in the gas yield. So that is why there is some return in terms of the technology usage and in terms of the increased gas yield. So you can see some example here, and the right side graph, it shows increase in the gas yield. These are real industry results. Okay, so you can see results from 4 different distilleries.
Dr. Bhandari, I think we'll need to.
Yes, next one please. Apart from the cavitation technology, we also work on biocoagulants, also work on newer nano biocomposites, adsorbents, because final polishing is required in tertiary treatment, and that is why we require process integration using cavitation, adsorption, coagulation and different techniques, so that we get ultimately the desired result. Next one. Okay, so this is the summary of the developed technologies, and in order to popularize this new concept and new development, hydrodynamic cavitation, we have published just 2-3 months back a book on hydrodynamic cavitation, John Wiley publication. Okay, earlier we published one book on industry wastewater treatment, recycle, reuse. That was in 2014. Next one.
Sir, sorry, earlier one I saw a cassia fistula and ghee somewhere. Ghee, GH.
GH2X.
Ghee, no, what we eat.
Ghee, right, yes.
What is that?
See,
is somebody extracting ghee out of this?
Right. So basically, I am quite impressed by our knowledge of Ayurveda, and I try to make use of Ayurveda knowledge wherever possible. So in development of newer adsorbents, I made use of natural ghee, cow ghee basically, for developing new adsorbents, and they had excellent properties. And for drinking water treatment, I have combined cavitation technology with the natural oils having antimicrobial property that are reported in Ayurveda. And it works wonderfully. It just disinfects water within minutes, which is otherwise not possible. Next one, please. So this is my group. We are also having one water center with IIT Bombay. So those industries which are interested, they can contact me or IIT Water Center for solving real life problems, because what you have seen is actually real life problem, and we are interested to see, because right now this technology is working in around 50 installations in industry, different industry sectors. We want to of course take it further, so that we have established water center with the help of DST, and you can contact me or water center in IIT Bombay. Next one. And of course, many of my students and postdocs have contributed. Dr. Lakshmi Gayatri Sorokhaibam, a brilliant scientist from Manipur, she worked initially in this project. Recently, we got award for innovation, and not for water treatment, wastewater treatment, but for desulfuration. We also use hydrodynamic cavitation for desulfuration of transportation oils, diesels particularly. And in 2019, we got award from our honorary Vice President of India. And Indian industry,
Bhandari
see,
sir, I think
last
we have to
concluding
conclude.
remark, Indian industry unfortunately is not interested in taking indigenous technologies. This is very unfortunate part. We as scientists are trying to develop technologies or work with industries, but industry is happy to go around and buy technologies, different technologies from outside, second-grade technologies from outside. So this technology, basically we have developed, but this is applicable only to refineries. And I have shown you one picture. You can see the site on your mobile, internet. One China company has this hydrodynamic cavitation implemented for desulfurization of fuel. And this picture on their website is my pilot plant. You can see yourself. This link is given there, vmets.com. Next, last. I think it's last one. Next, please. Yes. Thank you very much for your kind attention.
Thank you very much, sir.